All right. So this is stuff that we have gone over. Communication system is the process of conveying information from one point to another. Why do we do this? And what's the purpose of the communication system? The purpose of the communication system is to communicate information bearing signals from a source located at one point in space to a user destination located at another point. Three most common sources of information are speech or sound, video, and data. So regardless of the source, the information that is transmitted and received in communication system consists of a signal encoding the information in some appropriate fashion. So in layman term, there is a signal. Whether it is sound, video, or data. And in that signal, in that source, or that source is being carried by a system called communication system. This is a model. Just a model. There are various types of communication systems. But look at this one for a minute. We have the information source. I am talking here now. I'm the source. Well, actually, we are utilizing all three common sources, right? Because you're hearing my sound and you're getting this information in data form. And how would you say the video coming now? Okay. Well, primarily we are using data and sound right now. So that's the information source, right? So this is your communication system. It consists of three major components: a transmitter, and then once this is transmitted, it has to travel through some medium. And this medium is called the channel to get to a receiver. And the receiver now will convert that signal back into some other signal that we can use. Right? This might come in as electronic signal and it convert it back to a sound, data, or video. like any other thing, you encounter what we call noise. I don't know, well, you use the road, and some of you guys drive, so you hope that your drive on the road or your use of the road will be smooth, but it's not always so. And you can see that like what happened yesterday on Manning's Hill Road with that taxi driver. He would be considered as a noise on the road. The potholes are noise on the road.
Or the flooding in Runaway Bay, sir.
Huh?
Or the flooding in Runaway Bay yesterday.
Yeah, that's a noise on the road too. Right? So the noise on the road or the noise in your that get in your channel interrupt the smooth flow of the signal. Right? So we have to have that in the back of our minds that in electronic communication, we will encounter noise like anywhere else. So we have to know how to treat with it. So the purpose of communication system is to communicate information. What we look at above shows a general layout of a communication system. An input transistor example, a microphone converts the input message into the message signal. Okay. So there's a microphone on this laptop that I'm speaking to. And also a transducer. And that converted to some kind of voltages that will be transmitted to you. So that voltage is transmitted over a channel by means of a transmitter, which performs a very important function on communication signal by encoding the signal into some fashion, making use of a carrier signal and converted by a receiver to an output signal. All right? So that's sort of self-explanatory. The transmitter will now convert your input voltage that your transmitter, your transducer feeds to it and transmit that through some medium to your receiver, right? So here you see a lot of real engineering start coming in. Coding, decoding, encoding, decoding, and so on and so forth. When I get to the output transducer, like a loudspeaker, in our case, whether you're using a laptop or a phone, you have speaker. The good thing about what has been done is that we don't have to have a separate speaker for the input transducer and the output transducer. That is what we call multiplex. So we use it for both, right? So the information is contained in a so-called modulating signal that modulates a carrier signal. For example, in FM radio, the modulating signal consists of speech and music, and the carrier is a sinusoidal wave of predetermined frequency, much higher than the modulating signal frequency. So then, let's give noise a little bit of treatment before we jump into modulation. Let's properly define it because it's such a problem. So noise is the unwanted signal that tends to disturb the transmission and processing of signals in communication system. We classify two types of noise. Internal noise that is generated within the system, and external noise. So, examples of internal noise from the atmosphere are man-made or galactic. Internal noise, shot noise, white noise, and thermal noise. And we will get into a definition of those in due course. Information theory. Information theory provides quantitative measure of the information contained in the message signal and allow us to determine the capacity of a communication system to transfer the information from one source to destination. The information theory is used for mathematical modeling and analysis of the communication system. Types of communication system, which I'm going to give you the definition of. You have three major types. You have analog, hybrid, and digital. before I show you the definition of these, who can take a guess of what each is?
Sir, could you repeat the question?
I said I'm going to reveal the definitions now, or a definition of each of these. But who wants to take a guess? Who wants to take a swipe?
Well, sir, I'm guessing hybrid communication is a combination of both analog and digital communication.
Hmm?
Sure. Digital would be in a form of like email.
Sir, analog communication
Form of
is analog signal. Oh, sorry, sir.
Okay, go ahead.
Anyway, I can finish that one.
We basically don't talk. Or if you repeat also.
Sir,
Repeat,
could I continue?
repeat.
Right, so analog communication you send aside always, and digital communication uses things like video call and emailing.
Okay.
And hybrid communication uses both, just like what Steve said before.
All right.
Sir,
Okay.
to add to what Henry is saying, digital communication could be in the form of pulses of ones and zeros, where analog communication, the amplitude varies with time. There's no set high or low. And I guess hybrid communication, when they combine them, you get things like modems and them things.
Beautiful. 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 Yeah. You know, in a lot of sense now, you guys should be teaching me and not me teaching you, because when I was at CAS, I just analog communication we do. Everything, all the amps that we design, analog, right? It's later on in life we start learning digital. You guys come up and really skip over, for the most part, I mean, not entirely, over analog and jump right into digital. Although, just now, just so keep some of the props. We think that to learn an analog and design using analog is much more difficult than digital. Digital. So nobody beat my chest too fast. So here's what I have for analog communication. It's that type of communication in which the message or the information signal that is transmitted is analog in nature. That means it's continuous, right? The analog message signal may be obtained from sources such as speech, video, etc. Analog signals are continuous in both time and volume. Analog signals are used in many systems, although the use of analog signal has declined with the advent of cheap digital signal. Okay, so then this one then, because preferred mode is cheap. All natural signals are analog in nature. Right? So look over here what is said about the digital now. In digital communication, a message signal to be transmitted is digital in nature. This means that the digital communication involves the transmission of information in digital form. Digital signals are discrete in time and volume. Digital signals are signals that are represented by a binary number, 1 or 0. The 1 and 0 values can be correspond to different discrete voltage values, and any signal that doesn't quite fit into the scheme just get rounded off. Digital signals are sampled, quantized, and encoded version of continuous time signal, which they represent. In addition, some techniques also make the signal undergo encryption to make the system more tolerant to the channel. So what are the advantages? Increase immunity to channel noise and external interference. Right? So increase immunity. That's you boost a shot if you guys get the vaccine. Flexible operation of the system. So it's more flexible than the analog system. A common format for the transmission of different kind of message signal. Example, voice signal, video signal, computer data. Okay. Let us now look at the frequency range for different kind of transmission. FM radio. The modulating signal consists of speech and music, and the carrier is sinusoidal wave of predetermined frequency, much higher than the modulating signal frequency. So look at the table. Look at the table. Okay. You're gonna look at the frequency band, right? What we call it. What medium we use to transmit, and what kind of applications serve. So I just wanted to go through that table. Just read through it and digest. And I'm going to give you a couple of minutes, and then I'm going to make a little comment.
Dr. Watts, this document that you're giving us notes from, did you send us a copy?
No, I did not. But I can.
That would be lovely, sir.
Okay. So, you know, hi. You remember when you guys did electromagnetics, and we did like coaxial cable and wire pairs and waveguides and all of that crap. Look how it come together. Right? When you did your digital class and you were looking at, you know, ones and zeros and all of that. But in your mind, you wanted to be a communication engineer. No, the point I'm making is that, and for the love of me, I propose a little better, but it's very, very difficult in the grand scheme of things to fully get you to really understand. Because sometimes when you're doing like a course and you have to be asking, why the hell am I learning this? You know, you really get demotivated and you hardly want to study that topic because, you know, what this have to do with the price of China, price in China. But I'm saying that over the years, when institutions put together a curriculum for a certain course of study, you know, you sort of build on prior knowledge, right, to get to where you want to get to. And when you get there, you're like, oh, you almost want to go back to study what you never pay any attention to, right? Okay. So, major classification of communication system. You have your line communication, right? Your telephone, you know, you run wire all about underground overhead to get to your house. So all that information is transmitted over wire, right? Then you have radio communication. Right? So you have a tower, right? So you get the information to a tower close to you, right? And then you transmit it through air to an antenna on your TV TV or your radio. And then once you get that signal, it is decoded to what the original signal was. So let us go a little bit to get this signal to this transmitter. Right? Or to this tower. This signal probably be coming from Kingston to Hanover. So you will have to transmit that signal to another or close enough tower and then boost it and resend it Hello. Yes. Miss Campbell. Mr. Who? I don't know. Yes. Mr. Claude. I don't. Yeah. Okay. What you talking about? Mr. Claude. Carr. Where was I again? So you have to transmit, all right? You get the okay. So to get the information to where you want to get it to, you might have to retransmit it or boost the signal over the distance. That means you're not gonna just throw it up and it get there. So we classify these systems. The classification is based on the signal specification. So it's the nature of the information signal and the nature of the transmitted signal. So we classify system based on the signal specification, and we classify system based on the nature of the baseband signal, whether it's analog or digital. That's known as the baseband of the transmitted signal. Right? So the baseband signal can either be transmitted as it is without modulation or through a carrier signal with modulation. The two systems can be categorized as baseband communication system or carrier communication system. It all boils down to 4 major types of communication system. Analog, digital, baseband, and carrier. So all that, hope it was helpful, is to get to here.
Sir,
Yes.
if, would for the baseband signal, could you give like an example, practical, like like I was wondering, is not something like JPS signal? It would be something more like a telecommunication signal, or
I'm not hearing you there.
oh, sir, are you hearing me now, sir?
What? What? uh,
Sir, can you hear me now, sir?
No, I just hear one word and then you go blank and then I hear another word. I hope that's not how you hear. Huh? Go ahead again.
Can you hear me now, sir?
There are speaker.
Hello?
All right. Since I can't hear it, there are. Let me just try it. I'm going to assume that he's saying to clarify baseband signal. Right? So suppose you're a source, you're transmitted you're transmitting analog signal, right? And you know you go through the whole system as an analog signal, right? That means you don't convert it to any digital or what you work with. If you're transmitting a digital signal, you don't do any conversion, right? That's what you take it through the system the same way as it is transmitted. Is that what you're asking, Delroy? I think Delroy device is giving him problem. Okay, I'm gonna press along. If needs be, he can contact me later, and we go through that some more. So modulation.
A message in the chat. Just saying if you could give an example of a baseband signal.
Okay. Baseband signal. That would be like and they're not even make amplifiers like that anymore. But anyway, you see when they used to have those big amplifier, when I don't know if when people still go dance. So you have the those vinyl record, right? That you know, you put a needle on and it plays, and that's an analog signal, and the amplifier as an analog signal. All right? So you'd call the whole sound system set up as a baseband system, analog baseband system. Of course, nowadays, you know, you also have digital sound systems, but that would be like a good example of an analog baseband system. When you're DJ on the mic, the analog signal goes through the same way, and all the electronics in between, you know, your vacuum tube, transistor, and all that, treat the signal as an analog signal, amplify it, and do whatever, and move it along to the loudspeaker. Make sense? So, what is modulation? Well, it is a process that is performed at the transmitting end of the communication system. Mhm. So then, at the receiving end, we kind of do the reverse of modulation. So modulation now, let me put it in free language now. Modulation, you get the signal and you convert that signal first to a different signal so you can transmit that. So you an easier signal to transmit. Right? So going back now to the new type of sound system, you get you talk in a mic. You notice now that these mics, they don't have any cord anymore. Right? So the medium that it utilizes is space. Right? So that little mic is gonna convert your voice into the data thing, be transmitted over space to get to the channel. Or if you're using that as the channel all the way. Right? And when it reaches the speaker now, you have to get that information and reconvert it now to what you can listen to, the music. So that first step is modulation. And we're at the speaker end where we convert it to the original kind of signal is demodulation. You with me so far?
Yes, sir.
So you just find the transmitter of an analog communication system consists of a modulator and a receiver, which consists of a demodulator. So if we look back at just go back up here for just 1 second. Bear with me. So this transmitter, right? In this, you will have a modulator. In this receiver, you have a demodulator. Not saying that the whole component is just a modulator, a demodulator, but that must be in it. I am asking that. So that is modulation. Making progress now. If modulation is not employed, however, the person that's designing the system have some problem to deal with. And they are listed here. Just the noise, whole heap of noise interference. All right. I'm sure you guys can relate to the antenna height. You know, oh boy, what a waste. When I was returning home from the United States, right? And I'm a pack this container. One of the first things was a system to get me the different channels and all of that. Probably half of the 40-foot container was an antenna. And believe you me, I never even install that antenna. Because by the time I get around to it, you start find smaller antenna and cables start coming and all kind of things. So I paid all that money. And nobody would even beg me hit me give them and feel, you know, that may give it away. Throw it out. Right? So they are saying that these are some of the issues that you encounter if you don't modulate. So then, saying that to say this, you see the role that modulation play into where we are in communication systems today. the method. Basically, there are three ways to do it. And we're gonna look at these three ways. The three ways are really amplitude, angle, and pulse. Right? Here. We have some names for each of those. If you modulate using amplitude, that's where right? So now we're getting somewhere that we use terms that we use and we probably don't mean AM radio, right? The signal is channel, or the signal is modulated by amplitude and transmitted through the channel. First thing first, the carrier signal is always a sinusoidal signal. And here is a general representation of a sinusoidal signal. So let MT denote the baseband signal that carries the specification of the message. The source of the carrier wave is this. So now, essentially, what we are saying is that it's like you have a vehicle that transport you, right? So your vehicle is your carrier. And you're the information that the vehicle is going to transport. So you is independent of the vehicle, right? So somehow you and the vehicle gonna combine now and move from point A to point B. So the source of the carrier wave, CT, is physically independent of the source responsible for generating the information. Amplitude modulation is defined as the process in which the amplitude of the carrier wave is varied about a mean value linearly with the baseband signal. The amplitude modulate an amplitude modulated wave may thus be described in this most general form as a function of time as follows. Okay. Now, work with me now. Work with who can explain, based on what we just said, who can take a crack at explaining this equation? Anybody? Somebody have to help me. Somebody.
So so one would represent the baseband signal, and the K would be I'm not sure, is a constant.
Carrier signal.
The carrier signal.
Baseband are the carrier.
Okay. And
So if you do this now, just multiply it out. So then the carrier signal, right, was AC cos AC times 1 times cos 2 pi FTC. That was the carrier signal, right? Right? And the information signal now, the AC times this, right? Everybody get it?
so you just add the baseband signal and the carrier signal.
Yeah, yeah. So the transmitted signal ST, right, would be a combination of the baseband signal and the carrier, not the baseband, the carrier signal and the information signal. Because remember, you have your information that you're going to tie up. You're going to tie up on your carrier and send it to where it want to go.
And you said the KA is what is that KA again?
All of that now is your information. Empty. Go back to empty. Where did we first come across empty? Yeah, the source of carrier wave CT is physically in a source. Empty is the information. So you have your carrier and the information.
Okay.
So here we go. So then, now your math come into play. This is the same expression as above. So when you get this. I hope you remember your Fourier transform. So make sense out of that for me. So here, from this, we are plotting the information. And here, we are doing the same thing with the transformed frequency. We are plotting this. This is AC over 2. And we are plotting the, well, down here it would be minus. We are plotting this times this here. And again, it's frequency. That's what it looked like. So on a AM channel, on a radio, this is what the signal coming through the channel or through the medium looks like. All right. There is a plot now utilizing, this is the carrier signal. Right. and this is their baseband signal. So when you convolute those delta, you get this. And when we do the labs, which we will start next week, combine the two signals and see what they look like. Radio, tune the radio. So here we have, if we over modulate, we under modulate. So let's go back to the equation. Let's say again, when KAMT is less than 1, right? And when it's greater than 1. All right. At any point in time, remember your signal combination of your modulated signal, no, of your information signal and your carrier signal. That's your modulated signal. So here is the instantaneous value of your modulated signal or modulating signal. And here is the instantaneous value of your carrier signal. So this is the AM signal. Carrier signal plus your modulating signal. And you have to sit and take your time. I think the expressions are developed step by step. So you have to take your time and go through them. And understand the mathematics.
So I see one part where it looks like it uses harmonic analysis from physics. Yeah, when you add the amplitude.
Which one?
EC plus EM. Below the instantaneous value. EC plus EM sin omega MT times sin omega CT.
So, yes, what you say about that?
Oh, sir, I was saying them you add you can add the waves by harmonic analysis. Because so rain start falling, so I'm not sure if you go hear what I said.
Yeah, I'm hearing you. Only hoping that they will put St. Thomas or St. Mary. Because over there the rain and mash up.
Sir, I can step away. Sir, I have to pick up something off the line, sir. Sir, I'm actually on the campus.
Hear a word, yes. I hope your recording is going better though. All right, there, we get back to that. I'm not hearing you. So calculation of percentage of modulation. So M is the ratio of the modulating signal voltage to the carrier voltage. So this is the degree of modulation. this development, I think, is straightforward. If you have any question, let me know. So these are some of the things that you could be asked to calculate. Well, things like that. So depending on what you are given, you may be required to calculate them. The modulated carrier has new signal at different frequencies called side frequencies or sidebands, which occur in the frequency spectrum directly above or below the carrier frequency. So this is your lower band, and this is your upper band. Following, guys? So this first term represents the unmodulated wave or carrier. This is the carrier. This is the lower sideband and the upper sideband. Silence meaning are following exactly. So we know how to calculate power. So there's no mystery in calculating the power in the carrier, power in the upper sideband, or in the lower sideband. And the total power is the sum of all three. So here again, I can talk now. The virtue is the greatest, its greatest virtue is simplicity of implementation. What happened on the transmitter side and what happened on the receiver side. The AM radio is very simple. You can build that in the lab in 20 minutes. But it wastes power. I think that's a lot. That's a lot for you to absorb in one session. So, I want you to go over these notes. And let me know if you have any issues.
Dr. Watt,
Yes, ma'am.
what is the platform we're using for the class? Is it Moodle or we have a Google Classroom?
For the you mean right now?
Yes, sir.
We're just using Zoom for the time being.
No, sir. I mean, like, where you going to post the slide? Post it in the group.
I'm gonna post it in the group. So I'm gonna post it and you can go through it and let me know. So if there are no further questions, I would like to stop there with your permission, of course. And I'm sure I'll be hearing from you.
If you decide to, sir.
Okay. Turn it back for me. All right, well, let's start there for the day. If you want to go over the same thing, I'll be up and running again at 7 for the next group.
All right.
All right, cool.